Alright, so there's going to be a relatively quick lesson on 0.6 vector addition. So let's get started to do now. So let's say I travel 3 meters east, right? Because that's what the problem is saying. So I travel 3 meters east, and then I travel 4 meters north. And essentially what you're going to do here, what you're going to be doing here, is you're going to be calculating the displacement. Again, what is your displacement? Well, your displacement is where do you end up versus where you started, right? What is the length between your end and the start? How far are you from your starting point? That is my displacement. Well, how do I solve for displacement? Again, we talked about this in the previous classes. We solve for displacement by doing a squared plus b squared is equal to c squared. So I'm going to do 3 squared plus 4 squared is equal to c squared. So I'm doing 9 plus 16 is equal to c squared. And we get 25 is equal to c squared. And then I'm square rooting both sides to get 5. Well, 5 meters to be exact. And so that's my answer. So my displacement here is 5 meters. That's how far. And essentially what we've been doing this entire time, right? This method is actually called something called vector addition. This is called vector addition. Well, how do we add two vectors, right? Well, we draw a vector by first drawing a line and then an arrow. A vector has a direction. This arrow right here represents the vector's direction. And the length of that arrow represents the size of that vector, right? The magnitude, the number of that vector. So how do we properly add two vectors? Right, so let's take a look at the first example. We have a vector of 12, and we have a vector of 12, and I want to add another vector of 20. Well, how do I do that? Well, I have to connect the tail of this vector to the head of this one. Right, so this would be the head of the first vector, and I'm going to connect the tail of my next vector to the head. And so I'm going to name this 20. And well, what do we get when we combine these two vectors? Well, we get a combined vector of 32, right? 12 plus 20 gives me a 32. I'm not drawing this to scale, by the way. I'm not drawing to scale. Let's move on to the third row. Well, what happens when we have two vectors at perpendicular at right angles to one another, right? So let's say we have a vector of 10 there, and now you have a vector downward of 20. Well, how do we add these two vectors, right? What is my sum here, right? Well, clearly we added our tail of the 20 vector to the head of the 10 vector. But now what? Now what, right? So now we actually have to do what we've always been doing is we're using Pythagorean theorem, right? So I'm going to start from the start of our 10 vector here. And we'll make this arrow, I'm going to draw the arrow and end it at the 20. And furthermore, we're going to label this line right here. We're going to label this line as something we call R. Something we call R. So that's, and this R right here means that it is my resultant vector. All right? My resultant. But how do we solve for our resultant vector? The same thing we've been doing the entire time. We're going to do a squared plus b squared is equal to c squared. All right? So you're going to do a and b can be any side, right? It can be 10 or 20, and I'm just going to do 10 squared plus 20 squared is equal to c squared. So that's 100 plus 400 is c squared. That gives you 500 c squared. And then the square rooting both sides, well, that gets you 22.36, whatever that is, whatever unit. And then you get r there. And so this is your answer. This is how you would solve for your resultant vector, right? The result of adding two vectors is called the resultant vector. So let's do some practice, right? So we want to do the practice here. Let's do A, right? We want to draw the vectors and connect them using the head to tail method. And then we use the Pythagorean theorem to solve for the resultant vector. So for A, what we're going to do here is we're going to go draw 10 kilometers north. And so we're going to draw 10 kilometers north. We do that vector first. So this is 10 kilometers. And I'm going to draw 5 kilometers west there. 5 kilometers west. And this is how you would properly draw a diagram like this. And now I need to connect, right? I need to add these two vectors. What does these two vectors give me? I'm going to start here. And then draw the arrow there. And we'll label this R. Alright, I'm going to label this R. And again, I'm going to use my Pythagorean theorem. A squared, 5 squared plus 10 squared is equal to C squared. 25 plus 100 is C squared. 125 C squared, square root both sides, and you get something around this. And it's very important that you put the unit there, otherwise you're wrong. So 12.2 kilometers. And that would be my answer there, right? That would be my answer. And essentially you're doing the same exact thing for all the other problems. All right, so let's go back here. So let's do B. And so B's first vector is you're traveling west 30 kilometers. And then you're going 40 kilometers south. Right? And so now you're going to draw this vector right here. Right? So that's your resultant vector. That's your resultant. And, well, you do the same thing. You're going to do A squared plus B squared is equal to C squared. So you're going to do 30 squared plus 40 squared is equal to C squared. And if you want to do this yourself, well, the answer is... Actually, I forgot what the answer is. 900? Oh, it's 50. The answer here is 50 kilometers. So if you want to do it yourself, practice yourself, you know, there's the answer. So let's do C now. And so C is 30 meters per second west. So this is C. So you're going to go 30 meters per second west, and then you're going to go 100 meters per second north. So this is 30 meters per second west, 100 meters per second north. And then you're going to do A squared is plus B squared is equal to C squared again. I forgot the answer here actually, so you guys are going to do it yourself. But this is the proper way to draw a diagram, right? So you're going to connect the start point. And that's obviously not a perfect line, but again, we're going to label that R. Label that R. And the other ones you can do yourself, right? So D would be, then D, the diagram would be 50 meters east, and then you would go south, right? 70 meters per second. 50 meters per second. So then this would be your resultant. That would be your resultant. And then you would do A squared plus B squared C squared again. All right, moving on. Now, I'm sure you've seen this in math before. You've seen like a graph like this, right? Now, with this graph, we have to label, indicate our direction. So in physics, direction is very important. Direction is very important. Direction is so important that we assign direction to be negative, right? So in math, when we're making a plot like this, we know that if we go north, we go up, your numbers are going to be positive, right? And if we go right, our numbers are going to be positive. Now, if you go down or to the left, right? If we go down to the left, your numbers start becoming negative. Right? Your numbers start becoming negative. Now, this is how we're always going to define direction in physics. To the top and to the right is positive. To the negative, to the south and to the west is negative. And so how do we put that in action, right? How do we make sense of that? How do we make sense of that? Well, let's take a look at these example problems. So east would be positive, west would be negative. And so, well, I want to add these two vectors, or how would I add these two vectors? Well, I would do 5 plus -3, right? Your west indicates that the number is negative. We're going west here, right? We're going 5 meters east and then 3 meters west. So this would be +5 and this would be -3. And then you would get +2 meters. Moving on to B, north is positive, south is negative, right? So 10 meters north and then 7 meters south. So you would do 10 plus -7 gives you +3. Moving on to C, you're moving, this east is positive, west is negative. So you're going to do 10 plus -15, getting you -5 meters per second. Moving on to example problem D. North is positive, south is negative. So you're doing 9 plus -21 gives you -12 meters per second. And that's how I would add the vectors here, right? This is how you would add vectors. All right? So that's the end of the lesson.